say all that stuff again. Okay. But luckily you guys are already warming it up. Okay. So again, formative tomorrow, quiz on Thursday. Oh, talk to me.
Opens up.
You sure? Why?
Because it's x plus 1, that's the square.
Okay, so x is squared, so that's up, down.
Yeah.
And?
Positive. So
And the other number is positive. So it opens up. Love it. Bear, talk to me.
the vertex is -1, 2.
Love it. Because we're thinking opposite on both of those. So -1, 2 puts my vertex right there. Love it. Lex.
Okay, the focus is -1, 5.5 because you take the 14 and equal it to 4p, and then you get 3.5 or 7 halves.
Which is 3.5. Love it. Okay, and so since it opens up, the focus is up. Okay, so then this one would be, so this would be at up 3. 1, 2, 3.5 puts me right there. So you said -1, 5.5. What? No? You would rather have the decimal? Well, that makes one of us. Okay. Directrix?
It's y equals -1.5.
Because that one would be down 3.5 from the vertex.
Down 7.
Or down 7 halves, yes, excuse me. Well, 3.5, same thing. Yeah. Okay. Or down 7 halves. Yep. Love it. Okay. Okay.
The width is 14.
The width is 14, so that means what?
You go 7 from the focus right, and then left also 7.
Which then that allows me to draw it in, right? Yeah, buddy. Love it, love it, love it. Brett, axis of symmetry.
X equals -1.
Love it. Okay. So again, if this were Thursday, this would be a typical quiz question. Okay? And I'd ask for the 6 things. The only thing that would be different would be instead of this, I would ask for that one instead. I'd ask for the p-value instead of the direction of opening, because I would get the direction of opening off of the graph. Okay? Love it. Love it. Good job, everyone. Okay? So today we're going to go on to section 9.3. And in section 9.3, we're going to deal with it. It's only going to be a 2-day section. So we're going to deal with 9.3 today and Wednesday. Okay? It's an easy one because of what the topic is. There's not a lot with circles. Okay? Circles of the 4, circles are the easiest one because there's not much involved with it. There's no focus, there's no directrix, there's no all that other stuff, axis of symmetry and width and all that kind of stuff. It's just a circle. Okay? All right? So we can go through that one, or go through this section a little faster. Okay? All right? So let's start with what a circle is. So tell me, in your minds, what is a circle? Anybody? What is a circle? If I said, that's a circle, how do you know that that's a circle and not a square? If you're playing tic-tac-toe, circle gets the square. No corners, okay? So it doesn't have any corners. What else? Okay. 360 degrees. What else? You guys have all seen circles before, right? Give me some real-world examples of circles. Keanu, give me a real-world example of circle. The volume knob on your car. Love it. Anthony, give me one. A wheel. Okay. Give me another one. What? Oh, your eye. I thought you said I'm high. I'm like, I don't think so. Okay. Yeah, my eye, the eyeball. Okay. Yep. Like it. Scared there for a minute. Like, I don't think, but you know. One more. Steering wheel. Okay, a lot of car stuff. Okay, what about that clock? What about that speaker? What about that red dot on the door? Okay. Okay. What makes all of them circles? Or what do they all have in common? They're what? They're round. They're all round. Right? Okay. So they're all round. Okay. Now, a true mathematical description of what a circle is, or even a mathematical definition of what a circle is it is the set of all points equidistant from one point. A circle is the set of all points equidistant. Oh, there's that equidistant term again. We had it back last week in parabolas. What's equidistant mean? Equal distance. Same distance, right? Okay. So it's the set of all points that are the same distance from one point. Okay. So really, in a circle, there's only two things that you have to worry about. Okay. And those two things that you have to worry about are the center. Okay. The center is going to be this one point, and the radius. The radius is going to be this equidistant value. So the equation of a circle, of all circles, centered at the point h comma k, and that has a radius r, is this. X minus h, quantity squared, plus y minus k, quantity squared, equals r squared. Remember, inside a set of parentheses, how do we think? Oppositely inside a set of parentheses. Okay. The kicker is that r squared. Okay. So how am I going to find out what r is given r squared? We're going to square root it, right? Okay. So when we have this one, one big note, one big caveat is r will be in simplified radical form. Okay. So if r squared is 80, and I think here now the good one, 82. Okay, so if r squared is 82, I want it to be the square root of 82, because the square root of 82 is already simplified. Okay, I don't want it to be 9.1. Okay, I want it to be the square root of 82. If it was like, if it equaled 24, okay, I wouldn't want 4.9 as my radius. I'd want 2 times the square root of 6 as my radius. Okay? And we'll do problems like that as we go along. Okay? So, here we go. First graph. Okay? So, we've got, now, while you guys are writing this down, let me ask you, what is the tool that mathematicians use to make nice and pretty circles? A compass. It's called a compass. Now, do I require you to have a compass? No. Okay? I'm not making you have a compass. But can we think of some things that we know of that could possibly make us a circle relatively quickly and relatively pretty? Rubber band and a pencil. Okay. What else? Let's not even get that crafty. Pretty good craftiness.
A water bottle.
A water bottle. Okay. What else? What else is round around us right now? Not the roundest.
The cover.
The cap. The cap on a water bottle. Okay. What else? A straw or the bottom of your cup, right? Okay. You got a quarter there tomorrow? Or a dime or a nickel? Get where I'm going with this?
Yes.
Where am I going with it?
Use that as well.
You can use those as well. Quarters, dimes, nickels, pennies. Okay, they're all round too. Okay. All right. So you've got multiple things out there that can help you out. If not, try and draw it freehand as best you can. Okay. I will tell you this, and I have seen this before, and I've seen this on a test before. That is not a circle. Okay? And I have seen that before. Because again, remember, from your guys' definition, there's no corner, so we can't have a corner like that. So we're going to try and make it as round as possible. All right? So, here we go. Where, DJ, I think we're up to you. Where's the center here? -3, 1. Love it. Because we think oppositely on those. Yep. 1, 2, and 3. +1. Right there. There is my center. Okay. Radius now. 4 here. 4 is r squared. So I've got to square root both sides. Correct? Okay. Now, Kalia, big question. I've ingrained it on the insides of your eyelids because we've talked about it so much that whenever we're solving and we take the square root, what do we have to add in? Plus or minus, right? Okay, right? SP. Can I have a negative radius? No. So do we need to worry about plus or minus in this case? No, we don't need to worry about plus or minus in this case. So my radius here is just 2. Okay? If you want to still write plus or minus 2, that's fine. But when it comes up here to what the actual radius is, that is just 2, because again, it is a distance. Okay? Now, there are 4 easy points to graph that this circle will go through. Because remember, it's got to be 2 units away in all directions. So I'm going to go up 2, I'm going to go down 2, I'm going to go right 2, and I'm going to go left 2. So those 4 points, the up, the down, the left, and the right, those are all going to be the same distance away from my center. And so then, as best you can, you're going to draw in your circle. I kind of draw it in pieces. Okay. When I'm not lazy and do this. I have a circle tool. Anyway, it's kind of nice, not gonna lie to you. Yeah. Okay. Again, I am not going to dock you for having a non-completely rounded perfect circle. Unless it was like this one. I mean, I would dock you for this. Because that's not a circle. That's a square. Okay? Right. So, yeah, best you can. There'll be none of that. Go for it.
I've been sick for the past 2 weeks, and I don't think it's going away.
Yeah, and you've been sitting in the front row the past 2 weeks. Thanks.
You're welcome.
Should probably be sitting in the back.
We don't do that anymore. And you know what? It's been better. Because you know why?
Because everyone's paying attention.
Yep. Bear's not on Snapchat.
Those games like yours.
What do we got? 1, 0. I love it. Three. So that means I'm going to go 1, 2, and 3. 1, 2, and 3. 1, 2, and 3. 1, 2, and 3. I already don't like that one. Close enough. Nope. OCD. Well, I have it. I just don't want to, I don't want to brag. I don't want to flaunt it. You know what I mean? I want you to feel bad that you don't have a fan it's my fault because I didn't, go digital with this worksheet. Didn't allow you to put a, circle tool on there, an app, and there's got to be an app for that somewhere. Okay? What's wrong with this one? Right from the start, what's wrong with this one?
Not adding or subtracting. It's the coefficient.
There's a coefficient, right? Okay. Now, if you'll notice, if I go back to the last example, no coefficients on x or y, right? If I go back to the one before that, no coefficients on x or y down here in black. In the equation, no coefficients. So if you have coefficients on a circle, two things have to happen in order for it to be a circle. One, the coefficients on the squared term have to be exactly the same. If they're not exactly the same, it's not a circle. It's our next topic, which is an ellipse. Okay? Right? So that's the first thing. And the second thing is, if you have them, you got to get rid of them. So how am I going to get rid of the 7? What? Even easier than that. Divide everything by 7. Yeah, that's the first thing that I'm going to do is I'm just going to straight up divide every term by 7. That's going to give me x squared plus y squared equals 16. Yeah. So now, where's my center? No. Did you say 0, 0? Because there was a door slamming and I couldn't hear what came out afterwards. Okay, that's a good thing. Because you know where the center is? That's 0, 0. Okay. Bailey, back to you.
Yeah.
What's my radius then? 4. 4. 1, 2, 3, 4. 1, 2, 3, and 4. See, we've only been going for like 25 minutes right now, and we already know everything that there is to know about a circle. That's what I'm saying. Well, I mean, let's be honest, Billy. They all should be easy tests. Walked into that one, didn't you?
Yeah.
Tim? Oh, man. Did I skip it? Oh, I must have skipped it. Did I leave it as a warm-up for the next? Oh, no, didn't see it. Oh, we'll put it in as a warm-up for the next one. That's all right. All right. So, today we're going to talk front side. Actually, no, wait, tap the brakes. I do want to talk. What if I go back here? I just want to talk about this. We're not going to actually graph it because it will come up on a couple of them on this one. What if, let's go down here to the bottom. Okay. So what if I have an example of, let's say, x plus 4 quantity squared plus y minus 5 quantity squared equals 42. Okay? All right? So what's that? So what is the center of that circle? -4, 5. What is the radius of that circle? So what is the radius then, Logan? Don't do it. Because remember, how do we give radiuses? Simplified radical form, right? Okay. So start with the square root of 42, right? Okay. So it's going to be the square root of 42. Can the square root of 42 be simplified at all? Is there a perfect square factor that goes into 42? 1 does, 3 does, 6 does, 7 does, 14 does, 21 does, 2 does, and 42. So are any of those perfect squares? No. So as an answer, I want the square root of 42 as my radius. Using it wise, now there, go to it. What is the square root of 42? 6.6-ish? 6.48? 6.48. So it's about 6.5, right? So then I would go out in my 4 directions. I'd go out 6.5 units, okay, and draw my circle that way. Okay. So I'm not saying totally ignore the calculators because we need that to put that onto the graph. Okay. But when we give an answer, our answer is going to be the square root of 42. On the graph, it would be 6.5. Okay, right? And I only say that because there's 2 of those that show up. Okay. So, worksheet again for this week. This worksheet I will, when it's done, or I will collect the worksheet on Thursday. But I want you to do just like last week. I want you to do a front side